Hello, everybody. Today, let's simplify by factoring and assume that all expressions under the radicals represent non-negative numbers. Okay, to do this, we're going to break the x to the 19 apart into factors. And notice how we have a square root. And with a square root, this means that the index is 2. So in order to do this, let's break up 19 into multiples of 2. All right. And what I mean by that is we'll start with x to the 19. And then what we're going to do is we're going to break up x to the 19 as several x to the 2's. All right. And I need a lot of x to the 2's here. And I need to do as much of these so that the exponents add up to 19. So far we have 2 plus 2 plus 2 plus 2 plus 2, which is 10. And so I need to do more, which is, I'm thinking 12, but I don't want to write 12. I want to write 2 instead. And so now I know that when I add the exponents up, now I get 12. So let's keep doing x to the 2 until we get to 19. So this will be 14, x to the 16, x to the 18. But now if we go another x to the 2, that will give us 20, which puts us over 19. I don't want to go over 19. And so we figure out what the difference is, which is just 1, and that'll be x. All right. Okay, so when I do x to the 2 times x to the 2, etc., all these x to the 2's times x, I get x to the 19. And that's because when I have factors of the same base in this case being x, then in order to multiply those factors, I keep the same base, which is x, and add the exponents. So if I do 2 plus 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 1, that gives us 19. And let's double check this. 2, 4, 6, 8, 10, 12, 14, 16, 18, 19. So that does indeed multiply to x to the 19. Now, why do we do this? Okay, so there's a rule that says when you take the square root of factors, we can take the square root of each of the factors. So we'll have square root of x squared times another square root of x squared, and just keep doing this for each of the factors. All right, so we should have okay, there's a total of 3, 6, 9, 10 factors. So now we should have 10 radicals or 10 square roots. Let's see if we do. Yes, we do. All right. Okay, now here's the deal. So we can say x squared, and square root means the same as raising something to the 1/2. So the square root of x squared is the same thing as raising x squared to the 1/2. So we'll do each of these to the 1/2. Now this is a lot of writing, but we'll get to the answer, I promise. Okay, then we have square root of x, so that'll be just x to the 1/2. So there should be a total of 9 x squares, and do we still have 9 x squares? Yes, we do. And so what we have is correct so far. All right, I'm going to fix this. Okay, now why do we do all that? That's because if you take x squared to the 1/2, what we do is, notice that we're raising an exponential expression to an exponent. And so what we do is we keep the same base, which is x in this case, and multiply the exponents. So 2 times 1/2 is 1. So that would give us x to the 1, and x to the 1 is just x. So in general, x squared to the 1/2 is just x. So we'll have an x for each of these results. And then x to the 1/2 is just square root of x. All right, so now we should have a total of 9 x's and a square root of x, and we do. All right, so now, since we have x times itself 9 times, that would give us x to the 9 times the square root of x. And that's the answer for that one. Now, let's do the same kind of, so we have that one. And it says type an exact answer using radicals as needed. And so in the box, I would put that answer, x to the 9 square root of x. Now let's do a similar problem that says cube root of y to the 14. So here we'll employ a similar idea, except notice that this time the index is no longer 2 like it was in the previous problem, but now the index is 3. And so we call that cube root of y to the 14. So since we have 3, we're going to break it up in terms of y to the 3's, all right? So remember with index of 2, we broke it up into exponents involving 2. But now since we have index of 3, we'll let the exponents involve 3. So this is how it's going to work. Okay, so we'll have y to the 3, and we'll keep putting down y to the 3's until we get the exponents to add up to 14. So far we have y to the 3 times y to the 3. Well, that's 3 plus 3, which is 6. So that's y to the 6. So we still have more to go until we get to 14. So we'll do another one. That'll be y to the 9, because 3 plus 3 plus 3 is 9. Then we have another 3. That'll give us 12. And then if we put another 3, that will put us at 15, which is over 14. So to stop exactly at 14, this exponent has to be a 2. And let's make sure. So we have 3 plus 3. 3 plus 3 plus 3 plus 3, which is 12, plus 2 is 14. And so this is correct. So it is true that y to the 14 breaks up into y cubed times y cubed times y cubed times y cubed times y squared. And now we'll break up the radicals like we did in the first example. So we'll have a cube root of y cubed times 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 cube root of y squared. All right, now we'll raise each of these to the 1/3. So that's because if you take the cube root of something, that is the same as raising that something to the 1/3. So this will be y cubed, this raised to the 1/3, times y cubed to the 1/3, times y cubed to the 1/3, times y cubed to the 1/3, and then times y to the y squared to the 1/3. Okay, now we have y cubed to the 1/3. Again, we multiply the exponents. 3 times a third is 1. And that would give us y to the 1, which is just y. So we'll have y times y times y times y times, and this will be y to the 2/3. Because 2 times 1/3 is 2/3. And then we have y times y times y times y, which is y to the 4th. There's nothing we can, well, what we can do for this one. No, never mind. Okay, so there's nothing we can do with the y to the 2/3, and so we'll just rewrite this as cube root of y squared. And so this should be the final answer. So in the box up there, we just put in the answer y to the 4 times cube root of y squared. Okay, so that's how to simplify some radicals by factoring.